live on a relatively small planet, the surface of which is 2/3 water. In an eternal cycle, moisture from evaporation rises into the air, clouds form, condensation takes place. Snow and rain fall upon the earth to be distributed by river systems throughout the land, rivers which in turn flow back into the sea, so that the cycle can begin again. Historically, growth and economic development have always been dependent on ample supplies of fresh water. But today, advancing technology and expanding industry on a broad international scale have achieved a rate never before equaled. At the same time, however, management of water resources has not kept pace. It has become more and more apparent that one of the great problems facing the world is water and its proper management, its collection, its distribution, its disposal, and the interrelations that tie these features together, such as flood control, pollution control, conservation, recreation, irrigation, hydropower development, and reuse. To meet the critically urgent needs as they exist today and in the foreseeable future requires more than just ample supplies of fresh water. It takes the total planning of overall water management. The water problem has traditionally been considered a local or regional problem, but it is not local or regional. It is a continental problem, which requires a solution on a scale that is also continental. This motion picture is about the North American Water and Power Alliance, NAWAPA. NAWAPA has been conceived as one possible solution to help the collection and distribution segments of the overall continental water management problem. In terms of water, power, flood control, transportation, and recreational facilities, more than 33 of the states would directly benefit. In Canada, 7 provinces and 1 territory would directly benefit, as would regions in northern Mexico. On our continent, it is estimated that in less than 40 years, water usage for municipal, industrial, and agricultural requirements will more than double the figures for the year 1960. Growing needs are such that someday we may be able to meet those needs only by utilizing every means to procure fresh water. Where there are no resources of fresh water to develop, desalination is the only way. Therefore, continuing emphasis on research and development of desalination is important. It is, however, very costly to pump water from sea level inland. In this regard, it has been authoritatively stated that if the Mediterranean Sea were by some miracle turned into fresh water, the cost of transporting that water into the Sahara Desert would still make such a project prohibitively expensive. On the other hand, control of flowing rivers can be made to yield electrical power, which makes it cost practical to lift water to sufficient altitude so that it can be distributed by gravity flow. Development of the NAWAPA concept by the Ralph M. Parsons Company has been based on the company's long experience in developing water projects throughout the world to meet the great common need. It is a need that on our continent surely requires foresight and planning now for the full constructive use of water resources. For example, some areas are at the mercy of too much water, while others suffer from lack of sufficient supplies. And in other regions still, the priceless resource pours unused and wasted into the sea. Past and present water plans, and those currently under proposal, are stopgap regional or local schemes for taking water from one river basin with a current surplus and transferring it to a particular area suffering from a critical shortage. Desert areas of North America that can be brought to life with supplies of water at reasonable cost are well known. But actually, we are facing a water shortage in large areas of Canada and at least 25 of our 50 states and in Mexico. In cities with a population of 25,000 and over, speaking in the present and not looking forward to normal growth, 1 out of 5 water utilities is deficient in supply. 1 out of 3 show deficiency in ground storage, and more than half require distribution system improvements. In the Great Lakes area, Lakes Huron and Michigan are at their lowest level in 104 years. Canada has protested withdrawal of water by the city of Chicago, pointing to low water levels and impairment of navigation. The mayor of a Canadian city proclaimed, "We are a disaster area." Even at Niagara, power generation is restricted because of decreasing water flow. The shortage of water supplies is not a local problem. It is a continental problem. At a first or casual glance, the size of the North American Water and Power Alliance concept may seem unrealistic or fanciful. Closer and more thoughtful analysis of the concept, however, reveals it is not only imaginative, but that from an engineering viewpoint, it is feasible. From an economic viewpoint, it is realistic. In overall planning by the Ralph M. Parsons Company, the NAWAPA concept takes advantage of the geographical and climatological factors of our continent. Only water which is surplus now or in the foreseeable future will be used. In return for water, the supplying areas would be compensated in power or in some other tangible source of revenue. The primary sources of water collection are in southeastern Alaska, the Yukon Territory, and British Columbia. In the NAWAPA concept, only about 20% of the surplus water of the collection area will be used. 40% or more of the surplus could be made available. A series of dams and power stations will provide the power for pumping the water up to the Rocky Mountain Trench at 3,000 feet. The trench is a natural geological defile some 900 miles long, from 5 to 15 miles wide. About 500 miles of the trench would be utilized as the reservoir site. From the trench reservoir, water is pump-lifted to the Sawtooth Reservoir. From here, water flows southward by gravity via lined canals and tunnels throughout the system, passing the Sawtooth Mountain Barrier through a tunnel 80 feet in diameter and 50 miles in length. Continuing its gravity flow, the water will help meet the needs of the western part of the continent. Water for irrigation, power, recreational facilities, and other uses would flow for distribution to eastern Oregon, to Utah, to Nevada, California, Arizona, and northern Mexico. A diversion aqueduct in Utah would provide good quality water in bulk to those areas currently using Colorado River water with its excessive mineral content. That good water could, by leaching process, eventually recover thousands of acres of valuable farmlands, which have become degraded by the Colorado's excessive mineral content. On the east slope of the Rocky Mountains, water would be pumped by way of the Canadian and Purgatory rivers and distributed east of the Continental Divide. This water would be drawn upon by New Mexico, Texas, Colorado, Kansas, Nebraska, and Oklahoma. The Peace River Reservoir outflow and diverted flows from several streams on the east slope of the Rocky Mountains would supply the Canadian Great Lakes Canal. In excess of 40 million acre-feet per year would reach Lake Superior and provide for irrigation and other water demands of Alberta, Saskatchewan, Manitoba, and Western Ontario. This important part of the system would also yield considerable power. The Canadian Great Lakes Canal would alleviate falling levels and pollution of the Great Lakes, as well as augmenting the power potential of the Niagara and St. Lawrence rivers. Normal water levels then could also fortify water supplies in troubled eastern areas. The NAWAPA concept includes a seaway between Lake Winnipeg and Hudson Bay via the Nelson River. Another seaway would connect Georgian Bay with James Bay. A barge canal would connect the ore fields of Labrador and Quebec with the Great Lakes. These waterways would provide Canada with cheap ship and barge transport, thereby opening its iron ore, coal, potash, sulfur, forestry, and agricultural resources to extensive development. The waterways would also contribute to the economic welfare of Ontario and Quebec, Minnesota, Wisconsin, Michigan, Illinois, Indiana, Ohio, Pennsylvania, and New York, which are closely and historically associated with the Great Lakes. Branching off from the Canadian Great Lakes Canal, another canal large enough for barges connects with the Missouri and Minnesota river systems to serve the needs of Montana, Wyoming, North Dakota, South Dakota, Nebraska, and Iowa. Actually, all the Central Plains states and all those bordering the Mississippi River would benefit. The NAWAPA system will not interfere with any existing, programmed, or planned water and power development projects. NAWAPA is conceived as a bulk supplier of water and power and can support or augment projects planned or in being. Case in point, on the Columbia River development, NAWAPA can benefit the basin by regulating flows in the Columbia and Fraser River systems and thereby provide positive flood control and firm power throughout the year. At present, the Columbia's high water comes in early summer from melting snow and glaciers. But summer is the season of lowest power consumption. In winter, when water available for power is at the lowest level, demand for power is at the greatest level. The NAWAPA system is capable, in many areas, of providing the checks and balances to help make present developments more productive and stable. From the primary Northwest collection area alone, NAWAPA would initially deliver a total of approximately 110 million acre-feet of water per year. Its capability as compared to other projects, plans, and concepts is a realistic measure of its scope. It is estimated that a total of 30 million kilowatts of power will be required for the pumping systems. Since the total power generated is estimated at 100 million kilowatts, 70 million kilowatts will be available for sale at the bus bar at competitive prices. Income from the sale of power will keep water rates reasonable. A few basic statistics about NAWAPA are interesting. There will be mass earth movement of 32 billion cubic yards. Steel consumption will be some 30 million tons. 100,000 tons of copper and aluminum will be needed. Power and facility requirements will come to $10 billion. Construction equipment and tools will run some $5 billion. At present prices, the investment for land acquisition and relocation, engineering, construction, and contingencies is estimated at $100 billion over the 30-year period that will turn the NAWAPA concept into reality. Although the overall estimated investment is expended over the 30-year period of development, after about 9 years, returns will start coming in from sale of water and surplus power. Through a continuing and expanding sale of power and water as they become available, part of the total investment will be met by income. Ultimate annual returns will be more than $4 billion from the sale of power and low-cost water at competitive rates. In addition to the direct revenues derived from the sale of water and power, other benefits of great value would accrue to the three nations. Overall land values would increase, resulting in a broadened tax base. Tourism would benefit from formation of new scenic and navigable waterways. Recreational facilities would be expanded by the creation of new lakes. Fish and game resources would be appreciably increased. Positive flood control could be exercised. Business and labor, on an almost continent-wide basis, would share the benefits of a project of this magnitude. Both directly and indirectly, the impetus given industry would accelerate the annual growth rate of the gross national product and create thousands of new jobs. New industrial activity would be encouraged by the availability of water and power. It is true that before work can start, there must be treaties and agreements, and time for detailed survey and planning. This means far-sighted thinking and action at local, national, and international levels. The United States government, well aware that total water management is vital to meet future needs, is taking action by positive analysis of various water resources development plans. Of all these plans, the North American Water and Power Alliance, called NAWAPA, offers the greatest benefit not only because of overall size and scope, but also because of effective utilization of freshwater resources in the full meaning of total water management.